Alright, so we are going to do division with decimal remainders, running back through the steps of long division. Divide, then multiply, subtract, check, and bring down. Repeat this process over and over, stay organized, and we're going to be fine. So first thing I do is my division. 5 goes into 1 0 times. 5 is going to go into 10 twice. Notice how when I go into 10, my number goes right above where at the end, the 0. I'm only up to the 0, so it goes above the 0. Then multiply. 2 times 5 makes 10. Subtract. 10 minus 10 is 0. Bring down the 3. Right, I checked. 0 is less than 5, so I can continue. Brought down the 3. Next step, divide. 5 goes into 3. Well, 5 is larger than 3, so it cannot go into it, so I'll record a 0 there. It goes in 0 times. If I ever record a 0, then I can bring down the next number. Because the reason I can do that, if I multiplied it out, 0 times 5 would be 0, 3 minus 0 would be 3, and I'd be exactly back where I'm at. No need to waste that extra time. 5 goes into 37. That will be 7 times. 7 times 5 makes 35. That's my multiplication, then subtraction. 2 left. So I have 2 left over, but I want to get a decimal remainder. So if I looked at this as maybe $1,037 split between 5 people, right? Everyone would get $207, but then there'd be 2 extra bucks. So we want to split those 2 extra bucks. So I'm going to add a decimal point and some zeros. This is $137 and no extra pennies, right? There's nothing left over. It's exactly the same. I'm not changing the value. With this decimal point, I always raise the roof, bring it straight up, and then I just subtracted, so after that I check, I'm good, then bring down. 5 goes into 20 4 times. 4 times 5 makes 20. Subtract, I get 0. And there's nothing left. If it was money, you'd always go 2 decimal places, and I could say, well, every person would get $207.40. One more problem to try. If we pick a number like 24. A couple ways I can go. I can think of 24 like 25, or I'll show you another trick you could try. So 24 does not go into 4. It goes into 45. Maybe I'm not sure how many times, so I could potentially make a list of 24s, 24, then add 24, 48, add 24, so that would be 272, and I could continue on, 96, 100, 120, and continue on and make a list out. You could do that. I could think of it as 25 since it's really close to it and say, okay, 25 cents, 50 cents. That's too big, so it's probably only going to go in once. And if I look 24, 48, it's only going to go in once. 2 times is too big. So multiply, I get 24, subtract, I have 1 left, I have 2 left. Now 21 is a fairly large number for my subtraction, but in the checking step, 24 is still less than 21, so I'm okay. Then I will bring down, that's after checking, 24 goes into 210. I'm not 100% sure, but I know that if this was 25, it takes 8 quarters to make $2. 4 quarters is $1, so 8 quarters is $2. So I'm going to guess 8, because this is really close to 25 cents. 8 times 4 is 32. 8 times 2, 16, 17, 18, 19, 192. Wouldn't you know it, I'm pretty close to the number. becomes a 0, that becomes a 10, 8, 0 minus 9, I can't do it, so I borrow. 18, still a fairly large number, but it's less than 24, so I can continue. $450, so I would add the decimal point and a couple zeros. Raise the roof with your decimal point, it goes straight up. Bring down, 240 goes into 180. Well, 2 is going to go into 18 9 times, so I could try 9, or I could say 25 makes $1.75 with 7, so I think it's going to be 7. 7 times 4 is 28. 7 times 2 is 14, 15, 16. Subtract 12. Left. 12 is less than 24. Have to keep going. 24 goes into 120. Well, with this list, it goes in 1, 2, 3, 4, 5 times. 5 times 24 gives me exactly 120. Nothing left. So in this case, each person would get $18.75.